Okay, this should be similar to part C, except for instead of changing, it was the pressure, we're going to be seeing how many kilomoles we have to remove. Let's see, this says at a temperature of 20 degrees Celsius. This means we're at constant temperature. How many kilomoles can be withdrawn from the tank before the pressure falls to 10% of the original pressure? So what does all this in here mean? It means that we'll have our initial pressure, which is given, and our final state pressure is going to be equal to zero point 0.1 of the original pressure. Okay, so we're going to set this up similar to what we did in C. We know we have PV equals nRT, and this is our first pressure, our first volume, our first amount of kilomoles. We're removing how many kilomoles can be withdrawn from the tank. So we're going to be removing some of these. So we have to have an initial state. We have so many kilomoles at this constant temperature, and this is a constant. And for our final state, we may have a different pressure. We may have a different volume. We're definitely going to have less kilomoles. We're removing kilomoles to make this pressure turn into 10% of the original pressure. And that has the same R and T because temperature is held at 20 degrees Celsius. We already worked out that 20 degrees Celsius was equal to 293.15 degrees Kelvin. We know that, excuse me, we know that P2 is 10% of P1. And what we're going to do here, instead of dividing the fractions, we're just going to subtract. Because here, just let me show you what we're going to do. We're going to subtract into RT. We're going to subtract these two things. What does that give us? It gives us our, whoops, this should be a 2 here, shouldn't it? Yeah, wake up. That gives us P1 V1 minus P2 V2 is going to be equal to N1 RT minus N2 RT. And let's do a little factoring here, since is our volume changing? This is going to be withdrawn from a tank. Is a tank changing size at all? No, I hope not. So our V1 and our V2 should be identical. So if this V2 is actually V1, we can factor that out and we'll get our pressure 1 minus our pressure 2 times, we'll just call it V since it's not changing. And we're going to do these constants, R and T, we can pull those out and we'll have N1 minus N2 multiplied by R and T. And what is this? This is our difference in our moles, our kilomoles. This is what we need to solve for. So we're going to solve for N1 minus N2, our kilomoles minus our kilomoles, and that's going to be equal to our first pressure minus our second pressure times the volume over RT. Okay, from here, we know that P2 is 0.1 of this. So let's rewrite this. Our change in our kilomoles is equal to, we have P1 minus, well, P2 is 0.1 P1, and that's multiplied by our volume all over a constant. And by doing the simple arithmetic here, we have, well, what is this? If you're subtracting that much, you get 0.9 of your initial pressure. That quantity is going to be multiplied by your volume over RT. And let's start plugging in some numbers now. So your original amount of kilomoles minus this amount of kilomoles is equal to 0.9 times 1.5 times 10 to the 6. And let's go ahead and do our dimensional analysis over here. I always like to do that. And what is pressure? Pressure is a force per square meter. And technically that's what a pascal is right there. Your pascals are defined as your force per meter squared. Then we have our volume was 0.5, and that was volume's always in meters cubed. This is going to be divided by our ideal gas constant, which is 8.314 times 10 to the third. And that's in units of, what was it, joules per kilomole times Kelvin. Well, that was weird. I moved my screen over a little bit, but hopefully you can see that. It's kilomoles, and that's kelvins also. And then, of course, our temperature was 293.15, and that's our Kelvin up here. So let's cancel some of this stuff out. A joule is a Newton meter. So there's meters cubed. Let's get rid of these. Our newtons cancel, and we're left with our kilomoles. So luckily we've got N1 minus N2, our change in kilomoles, to give us our particular pressure of 0.1 of the original pressure is going to be equal to a grand total of 0.277, and this is kilomoles. Alright, see you in the next video.